Regina, not pronounced Regina, it's Regina. In Regina, Saskatchewan, the average mid-afternoon temperature in January is negative 12.6 degrees Celsius. The average mid-afternoon temperature in July is 26.1. How many degrees colder in Regina is January than July? When you have a story problem, always try and draw it. Now, because this is temperature, a lot of the time we can kind of think of it as a thermometer. And thermometers are usually vertical. And I think I can get this. So I'm going to put the low down here, negative 12.6. We've already done this one, haven't we? But I'll put it on video anyway, so you have it posterior. There's the low. There's the high. And 0 would be approximately here, I would say, right? Is that right? Maybe. Reasonable. The question said, what's the difference, or how many degrees colder is Regina in January? So what's the difference between this one and this one? What's the difference? What's the difference? Meaning, Zach, what operation do you think of when your teacher says, what's the difference? Jojo knows. Jojo knows everything. Subtraction. Correct. So if I say the difference between the high, take away the low, that would be the difference between them. Or if I say the high, 26.1, take away the low, which is negative 12.6, that's going to be the difference between, or the distance, if we want to think distance instead of difference, between those two. Keep, flip, change. Don't grab a calculator. Use your brain. 38.7 is the difference. So step 1, draw a picture. Step 2, make an expression. Step 3, solve the expression. Step 4, write a sentence. Therefore, the difference is 38.7 degrees Celsius. Piece of cake. Agreed? One January day in British Columbia, the temperature read negative 6.3 degrees Celsius at 10 a.m. and 1.4 degrees Celsius at 3 p.m. What was the change in temperature? Now, we could use a thermometer here. I'm going to use just a straight old number line because I'm going to have two parts to it. On the top, I'm going to put, or on the bottom, I'm going to put my temperature. It was negative 6.3 degrees Celsius, and then it became 1.4. So we see this progression of warming on that number line. We also can add time here. We can put it 10 a.m., and we can put 3 p.m. Okay? That's my number. That's my picture. And then I say, what's the change in temperature? So again, the change in temperature would be the difference between my high and my low, right? So for A, what I want you to write for your A is the difference between the high and the low. Between the high, the difference between the high and the low. If that makes sense to you, great. If it doesn't, well, hopefully we'll figure it out. That's what the question is really asking. What is the change in temperature, or the difference between the high and the low? Keep, flip, change. You can do that without a calculator, I hope. Therefore, the answer is 7.7 degrees Celsius. The difference, therefore, the change, is it rising 7.7 or going down 7.7? Yeah, it's positive 7.7. It went up 7.7 degrees from the morning to the afternoon. Now, the second part is a little tricky, but not really. What's the average rate of change? So, again, if I asked Jojo, you had 2 80s and a 90 on 3 of your tests. 2 80s and a 90. I said, what's your average test score? How would you calculate your average? If you had 2 80s and a 90, what would you do to get your average test score? Do you know? Close. Does anyone know? So to calculate your average, what you would do is you would add your 80 plus your 80 plus your 90, get a sum, and then you would divide that by 3 because you had 3 tests. So if I had Joey, you had an 80, 80, and 90, so you go 80 plus 90 equals 250. That's 3 tests, so divide that by the 3 tests you had. Your average score would be 83 1/3%. No, because you want to add them up. So the sum divided by the number. So if we take that logic and apply it to this question, what's the average rate of change? 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock. I've now added numbers, so 11 o'clock, noon, 1 o'clock, 2 o'clock, 3 o'clock. How many hours exist between 10 and 3? There's 5 of them, right? 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, correct? So the same way that we calculated Joe's average, we could say if you take the average rate of change divided by the number of hours, which is 5 hours, and use your calculator because it's not something that's going to be easy, you get 1.54. So what does this mean? This means on average, every hour on average rose approximately 1.5 degrees Celsius per hour. So the rate of change is approximately 1.54 degrees Celsius per hour. Does that make sense? On average. Okay. A pelican dives vertically from a height of 3.8 meters above the water. I better shrink this question down. It's kind of big. It then catches a fish 2.3 meters underwater. Write an expression using rational numbers to represent the length of the pelican's dive. So first thing you're going to do is draw your freaking pelican. Now I saw some drawings that were incredibly complex. The pelicans were like art-worthy stuff. In your drawing, you don't need to be overly artistic. I have my pelican looking like an M, and my water looking like waves, and my line of diving looking like that. I know he's going underwater, so I need to have my line extend under the water because it says so right there. Now I add my information. I got 3.8 meters above the water, so from here to here is 3.8 meters, and from here to here is underwater. He went 2.3. I'm going to represent that properly because I'm a big boy with negative. I'm going to represent distances underwater as negatives because we're trying to use our rational numbers in decimal form. So the difference between the height and his depth is this distance here. So the difference between the height and the depth, that's my expression, just like we have been with the other questions. Keep flip change. Don't use a calculator if you don't have to. It should be 6.1, correct? So therefore, the distance he traveled is 6.1. So this point here, this is the expression. That's A. How long is the pelican's drive? 6.1 meters. How far do we have to go for homework? 14? Okay. I love question 13 so much I can guarantee it's probably on your test. It's such a good question. A submarine was cruising at a depth of 153 meters and then rose at 4.5 meters per minute for 15 minutes. So after 1 minute, how much did it rise? 4.5 meters. After 2 minutes, 9 meters. After 15 minutes, it's going to take a little finagling. But it says, what is the depth of the end of this rise? So step 1 is draw a picture. So I have some beautiful water here. I have a beautiful submarine. That looks like a submarine, doesn't it? Caden, beautiful submarine? Yeah. Did it go up or down? Did that submarine go up or down? Caden, the word rose is not just a flower. It means go up. To rise. It rose. It rose. Like there. There's my arrow showing it rose. How far did it rose? Well, it went 4.5 meters per minute. For how long? For 15 minutes. There we go. There's my picture. Isn't it pretty? How deep was it? Right. It was. So I'm going to put this in here as well. It was 153 meters underwater. There we go. There's all the information on my picture. It's a beautiful picture. The best of pictures. So if I want to calculate how far it rose, if I think about words, this is A, where it started, plus how much it rose will equal where it is. A lot of students skip this step. I love writing it in words to make sure it makes sense. where it started plus how much it rose equals where it is now. And once I write that, then making my expression make sense. Where it started, negative 153, because it's underwater, plus how much it rose. Riley, how do I calculate how much it rose? How do I figure out how much that is? 4.5 times 15, right? Right? Because for 1 minute, it rose 4.5. 2 minutes. Is that a positive 4.5 or a negative 4.5? Because it's rising, right? So we're going to say 15. Well, you know what? I'm going to use those square brackets. Ooh, this is fun. Square bracket time. 15 multiplied by 4.5 in square brackets. So where it started, 153 underwater, plus how much it rose, that will be where it ends up at. Bed mass. What do I do first, Riley? Add or multiply? Multiply. 4.5 times 15. It rose 67.5 meters. Square brackets now, it's fine. Negative 153 plus it rose 67.5 meters. Use your calculator because it's available to you. 153 underwater, negative, combined with the rising of 67.5. It is now, so therefore, it is now 85.5 meters underwater. Notice how I decided to use no negative sign. How come I didn't have to use negative sign in front of the 85.5? Why is there no negative sign in my answer with the therefore symbol? Abby, you're smart. Why is there no negative sign? Why did I forego the negative sign? Because I used the word underwater. That negative sign represents underwater, right? So because I used this word underwater, I kind of replaced the negative sign with that. Does that make sense? Yeah. Okay, second question. If the submarine continues to rise at the same rate, how much longer will it take to reach the surface? Now this is complicated. I don't think anyone solved it with algebra. I'm going to show you what it is. So I'm going to put down B, and I know that I am currently at a depth of 85.5 meters underwater. If I rise at 4.5 meters, I don't know how many minutes, correct? I want to solve how many minutes. That's what you studied algebra for. If I say rising 4.5 meters multiplied by the number of minutes, so x is going to be the number of minutes. You with me? So 4.5 multiplied by the number of minutes, x. How much does this have to equal for me to rise to the surface, Riley? How far do I have to travel again to get to the surface? 85.5. I want you to look at that equation and see if that makes sense. Rising 4.5 meters per minute equals 85.5 meters. If I solve it with algebra, what operation am I using? All I'm really using is division. If I divide the depth I need to travel by the 4.5, I will realize that 85.5 meters divided by the 4.5 meters a minute equals 19. Therefore, it will take 19 minutes to reach the surface. Did anyone solve with algebra? Just out of curiosity. Does it make sense to solve with algebra? It does, doesn't it? Kind of, maybe, sort of. Now that you see it, you're like, ooh, that's interesting. Store that in one of the data banks. Maybe, maybe not. Last question is question 14. It says Sadia owns 125 shares of an oil company. One day, the value of each share dropped by 31 cents. The next day, the value of each share rose by 18 cents. What was the total change in the value of shares? So if I think about stocks, if I think about the day one change combined with day two equals the total change. If I start with this wordy sentence, I can then think, okay, I know exactly what I have to do to create this. So day one, the shares dropped by 31 cents. Will that mean we use a positive or negative integer? Negative. So I have 125 shares, and each one of them dropped 31 cents. So if I take every one of my 125 shares and multiply it by a drop of 31 cents, that's what the value changed. And if I combine that with day two, which was a much better day because the value of the shares rose by 18 cents, though those same 125 shares rose by 18 cents. Right? Now, how much were the stocks worth? It doesn't matter. If the stocks were worth $1,426, if each one of those 125 shares dropped by 31 cents, then the value of those stocks for the first day is 125 shares multiplied by each one of them dropped by 31 cents. It drops by $38.75, meaning day one, the value of those stocks, which I was so proud of, lost $38.75. But then day two, they went up. And I was like, thank God, I was worried. The 125 shares rose by 18 cents, meaning it went up by $22.50 on day two. Okay? Day one, I lost $38.75. Day two, I gained another $22.50. If I combine those using my calculator, so 30, what was it again? 38.75 plus 38.75 negative. Overall, after 2 days of the stock market, whatever I paid for those $125, doesn't matter. I could have paid for those 125 shares. I might have paid $14,000 for those 125 shares. But at the end of 2 days of trading, those value, for whatever it was worth, those 125 shares are now worth $16.25 less than I paid for them. Okay? Make a note of that little check mark right there. Words are great to get your head around what you have to do. Once you have the words, this becomes a lot easier. You simplify it, you solve it.